For the last example problem in this chapter, we have example problem 3.3. So let us first analyze this figure. We have balls 1 and 2, and each ball has a different mass. The mass of ball 1 is 150 grams or 0.15 kilograms, and for ball 2, that is equal to 0.26 kilograms. So the initial velocity of ball 1 is 0.9 meters per second directed in this direction, and for ball 2, that is equal to 0.54 meters per second directed to the positive x direction. So these two balls will collide, and after collision, they will have a different final velocity. So for the first ball, the final velocity, its magnitude and direction is unknown. And for ball 2, the final velocity is 0.7 meters per second. So we are asked to find the magnitude and direction of the final velocity of ball 1 after the collision. So that is v sub f1 and the angle theta. So in order to solve this, we will use the principle of conservation of linear momentum, and we have to divide this into components. First, let us consider the x component. So for the x component, we have, so this is positive. So 0.15 kilograms times 0.9 meters per second squared sine 50 degrees plus, again positive, 0.26 kilograms times the initial velocity of 0.54 meters per second. And this is equal to the final momentums, 0.15 kilograms times v sub f1x, or the x component of the final velocity of ball 1, plus, again positive, so 0.26 kilograms times 0.26 kilograms times the velocity 0.7 meters per second times cosine 35 degrees. So solving for v sub f1x, this is equal to 0.6313 meters per second. For the y component, we have again 0.15 kilograms times, since the component of this velocity is downward, so we will write negative 0.9 meters per second times cosine 50 degrees. And since the second ball is initially directed to the positive x-axis, it has no y component. So we will now move on to the other side. This is equal to 0.15 kilograms times 0.15 kilograms times the positive y. So let us assume that this is V sub F1y. And plus, so 0.26 kilograms times 0.26 kilograms times, again, the y component is directed downward. So this is negative 0.7 meters per second times sine 35 degrees. So V sub F1y is equal to 0.1174 meters per second. So for the initial component, for the magnitude of V sub F1, this is equal to the 0.6313 meters per second squared plus 0.1174 meters per second squared. So V sub F1 is equal to 0.6421 meters per second. But this is only the magnitude, and we are also asked to find the direction. So its direction is denoted by the angle theta, and we will simply use the arctangent function, arctangent of 0.1174 meters per second all over 6313 all over 0.6313 meters per second. Cancel, and theta is equal to 10.53 degrees.